Solving quadratic equations by the quadratic formula. So the quadratic formula, if you have a, b, and c are real numbers and a is not equal to 0, a quadratic equation written in standard form, ax squared plus bx plus c equals 0, has solutions of x equals, here's your formula, opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So this is your quadratic formula. Now, I will tell you that if you have a quadratic equation and the quadratic is in standard form, no fractions, everything set equal to 0, then you can use the quadratic formula. Your coefficient of your x squared term is a, your coefficient of your linear term is b, and then your constant, of course, is c. And if any of these are missing, you can replace it with a 0. So when you plug into the quadratic formula, we don't want any variables. That's what we're solving for. We're solving for the x. And so you're going to have x is equal to the opposite of your b coefficient plus or minus the square root of b squared minus 4 times a times c all over 2a. Alright, so let's try this one. It says solve 11n squared minus 9n equals 1 by the quadratic formula. So, first things first is we want to get this in standard form, which means it has to be set equal to 0 in descending form. So, we're going to have 11n squared minus 9n minus 1 equals 0. All I did was minus 1 here, minus 1 here. Alright, so now I have it in standard form, and I have no fractions. So we're ready to use the quadratic formula. So a is going to be my coefficient of my squared term, b is going to be the coefficient of my linear term, and c is going to be my constant. Alright, so the quadratic formula states x equals opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So b is negative 9, and the opposite of negative 9 is going to be a positive 9. Plus or minus is where your two answers are going to come from. The square root of b squared, which is going to be negative 9 squared, minus 4 times a, which is 11, times c, which is negative 1, all over 2 times a, which is 11. From here, we're just going to do the math. So we'll have 9 plus or minus the square root. Negative 9 squared is going to be 81. Negative 4 times 11 times negative 1 is plus, negative times negative is positive, 44. All over 2 times 11, which is going to be 22. So we're going to have equals 9 plus or minus the square root of 125 over 22, and that's going to be 9 plus or minus, and we need to rationalize that 125, so we're going to get 5 root 5 over 22. And this will not reduce, so this is going to be your answer. There are two answers here. You have 9 plus 5 radical 5 over 22, and you have 9 minus 5 radical 5 over 22, which will give you two totally different decimals. So understand there are two answers here. Alright, so let's try again. We're going to solve this quadratic equation by using the quadratic formula, which means we need everything set equal to 0, done, and we don't want to have fractions in there. And we don't want to have fractions because we're going to be doing a lot of math, and it's easier to do math with whole numbers rather than fractions. So when you have an equation that has fractions in it, remember to get rid of those fractions, you're going to multiply everything by the common denominator. So the common denominator between 8, 1, and 2 is going to be 8. So I'm going to multiply everything by 8. So I'm going to have 8x squared plus 8x, because there's a 1 here, minus 2 will go into 8 4 times, and 4 times 5 is going to be 20, is equal to 0. And that should not be an 8 up here. That should just be an x squared, because 8 cancels out with the 8, leaving you with 1. So you just have x squared plus 8x minus 20 equals 0. Alright, so again, your a is your 1, b is going to be 8, and c is going to be negative 20. So we have x equals opposite of b, which is going to be negative 8, plus or minus the square root of b squared, which is going to be 8 squared, minus 4 times a, which is 1, times c, which is negative 20, all over 2 times a, which is 1. Alright, so let's do some math here. Figure out what x is equal to. We have negative 8 plus or minus the square root of 8 squared is going to be 64. And then negative 4 times 1 times negative 20 is going to be a positive 80. Just do all that math, type all three of those numbers in your calculator at one time so you don't get mixed up on your signs. All over 2 times 1, which is going to be 2. So we have x equals negative 8 plus or minus the square root of 144 all over 2. And so we have x is equal to negative 8 plus or minus 12 over 2. Now, the difference in this problem and in example 1, in example 1, since we had whole numbers and radicals, we couldn't go any farther unless we come up with a decimal, and I don't really want that. Here, however, the radical went away and I have all whole numbers, and we know how to do math with whole numbers. So remember, you have two separate problems here, okay? We have negative 8 plus 12 over 2, and we have negative 8 minus 12 over 2, which is going to give us two separate numbers. So negative 8 plus 12 is going to give us 4. Negative 8 plus 12 is going to give us 4 over 2 is going to be 2. And then negative 8 plus 12 is going to be 20 over negative 20 over 2, which is going to give us negative 10. So your two answers are 10 and negative 2. Alright, example 3. Again, this is not in standard form. It's got to be in standard form. Remember, it's got to be ax squared plus bx plus c is equal to 0. Well, our first problem is we have parentheses. Definitely don't need parentheses. So we're going to use the distributive property and get x squared plus 6x equals negative 30. The next thing is we need it set equal to 0, so we're going to have x squared plus 6x plus 30 equals 0. And now we're ready to use the quadratic formula. So we'll have x is equal to the opposite of b, which is negative 6, plus or minus the square root of b, which is 6 squared, minus 4 times a, which is 1, times c, which is 30, all over 2a. So we have x equals negative 6 plus or minus the square root of 36, 6 squared is going to be 36, minus 120 all over 2. And so we have x equals negative 6 plus or minus the square root of negative 84 all over 2. So there is no real solution. And the reason being is because you have a negative under the radical. When you have a negative under the radical, there is no real solution. We have an imaginary solution, but not a real solution, and we haven't talked about imaginary numbers yet, so no solutions. Okay, let's try this one. Approximate the exact solutions of 12x equals 4x squared plus 4. Round to the nearest tenth. Now, when you solve this, and we're going to be dealing with radicals. When you solve with radicals, these are called irrational numbers, which means the decimals go on forever and ever. And so when you have to round a decimal, you are approximating, which means it's approximately this answer, but not exactly this answer. So we are approximating the exact solution. We can't give the exact solution because we're rounding. Alright, so let's take this quadratic and get it in standard form. So the first thing we need to do is we need to get that 12x in here where it goes. So we're going to have 0 is equal to 4x squared minus 12x plus 4. Alright, so let's turn that around so it'll look familiar to us. We'll have 4x squared minus 12x plus 4 equals 0. So we need it in descending order and everything set equal to 0. So we're ready to go here. So we're going to have x equals the opposite of b, which is going to be 12, plus or minus the square root of b, which is negative 12 squared, minus 4 times a times c, all over 2 times a. And so we'll have x is equal to 12 plus or minus the square root of 144 minus 64, all over 8. And so we have x is equal to 12 plus or minus the square root of 80 over 8. Alright, so if we keep going here, we'll have 12 plus or minus 4 root 5 over 8. And so let's go ahead and reduce that, because I can reduce all of those, the 12, 4, and the 8, all the whole numbers by 4. So that's going to give me 3, 1, and 2. So coming up here, we have x equals 3 plus or minus root 5 over 2. And so what I want to do is I want to approximate the exact solution, okay? So if I left it like this, this would be the exact solution. But when you go out into the real world and you're talking to maybe construction workers or factory workers that are building parts on machines or whatever the case may be, and you tell them, hey, I need this piece to be 3 plus or minus the square root of 5 over 2 inches long, they're going to look at you and say, what? So we need to be able to give an approximation, and that's pure calculator work. So in your calculator, you're going to do 3 plus the square root of 5, and that's going to give you a decimal, and then divide that by 2. And you're also going to do x equals 3 minus the square root of 5 over 2. And so what you're going to have is you're going to have x is equal to 2.6 and x is equal to 0.4. So you may say, okay, this piece of machinery can range between 2.6 and negative 4. And when you get into calculus, we'll do some things with these numbers called differentials, and that will help you to apply to real world even better.